Dhanasega is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. We are having the subject that is compiler design. So, in the previous episode we have been studying the ambiguity and the elimination of ambiguity available in the grammar. A grammar is said to be ambiguous grammar if there exists an ambiguous sentence, and a sentence is said to be an ambiguous sentence if there exists more than one parse tree or more than one leftmost derivation or more than one rightmost derivation. And we have seen how the ambiguity available in different grammars are getting eliminated. So, there is no standard algorithm or procedure for removing the ambiguity, but we will try to find out what is the reason for the ambiguity, and once the reason for the ambiguity has been identified, we will be able to remove the ambiguity by rewriting the productions. That is what the topic we had seen as far as the previous episode is concerned. And now we are having another issue being faced because of in grammars, that is called the lift recursion. So, we know that the grammars are used for constructing the parsing table, and the parsers are making use of the parsing table for parsing the sentences, and the parsing can be done either in top down fashion or even in bottom up fashion. So, if you are constructing the that is parse tree from bottom to top, we will be calling the parsing as bottom up parsing, and those parsers are called bottom up parsers. And whereas, if you are constructing the parsing in top down fashion, we will be calling the parsing as top down parsing, which will be constructing the parse tree from root to the leaf nodes, and the parsers are called top down parsers. So, when you have the top down parsers, so we must ensure that the grammars should not be left recursion. So, left recursion, first of all we should know that what is a left recursion, and then there is another factor, another problem with this grammars used by the top down parsers is called the left factoring. So, both the problems must be completely eliminated from the grammars, so that the resulting grammar could be used for constructing a parsing table used by any top down parser. Actually, we are having two different top down parsers, one is the predictive parser and the other one is going to be the that is recursive descent parser. But in either case, the grammar to be used for constructing the parsing or the constructing the parsing table should not have left recursion and left factoring. So, now we shall see that is what is the meaning of left recursion and then how this is going to be eliminated. So, here we have the situation like that is a grammar G is said to be a left recursive, that is you are given a context free grammar and we will be calling that grammar is going to be left recursive. So, if it is having a non terminal a such that there is a derivation of the form a derives a alpha for some alpha. So, here we know that the a is going to be a variable and alpha is any essential form having the combination of variables and terminals one or more or even including that is epsilon also. So, we find that that is the derivation on the left hand side we are having a variable called a, that is a non terminal, and the right hand side immediately it starts with another variable, that is variable which is there in the left hand side of the derivation. That is what we call it as a derives a alpha, but it is not required that it must immediately start with a. Even after some number of steps, if you find that it starts with a, so we will be going for a recursive kind of nature. So, we know that the top down parser construct the parse tree in a top down fashion, and if it is done in a top down fashion, so what will happen is the leftmost variable is going to be the first one expanded. So, if the leftmost variable is expanded by using its parent, as far as the parse tree is concerned, its parent is going to be the one which is having which is on the left hand side of the production. So, if the left hand side of the production is expanded using once again the left hand side of the same variable, that too in the first position, what will happen is the tree grows in an recursive manner, or tree grows in an infinite manner, but without consuming even a single symbol from the input. So, even if you are allowing it to grow in a recursive manner, if it is consuming some symbol from the input, we will find that there will be some progress on the parsing process. But here the situation is, we will be keep on expanding the leftmost branch of the parse tree by using the parent or some node or some variable on the ancestor position. So, we will find there will not be any progress as far as the parsing is concerned, but the tree grows in an infinite manner, that is the number of levels available in the parse tree gets increasing every time, but there will not be any progress as far as the parsing process is concerned. So, if you are leaving this left recursion in the grammar, then definitely we will not be able to parse any sentence. So, that is the reason why we are trying to avoid the left recursion available in the grammar, so that the grammar will become a non left recursive grammar, which could be given as input for the constructing any top down parser. So, these type of parsers or grammars are that is causing the top down parser to go into infinite loop without consuming input symbols, and this, that is left recursive, the left recursion may be directly available or can even be indirectly available. So, if it is directly available, we will be calling it as immediate left recursion, where instead of expecting a product, that is derivation of the form A derives A alpha in some number of steps, it is enough to have a production of the form A derives A alpha. So, that is also possible. So, here we have a production, that is if it is A derives A alpha, immediately we can say that there exists a immediate left recursion, because of the right hand side of the production for A starts with A itself. So, this is called an immediate left recursion. So, the recursion can be either immediate or it can be directly indirectly available, but in either case we must find out it, eliminate that by rewriting the grammar, so that we will be having the new grammar which does not have a left recursion, and if it is not having left recursion, we can go ahead with constructing the parsing table either for predictive parsing table or it can be a recursive descent parser. So, now the question is how will you eliminate the that is left recursion available in the grammar. So, we have an algorithm for that, how we are eliminating the left recursion. So, if it is directly available, we have a simple procedure for transforming the productions, so that the new set of productions will be not having any left recursion. And if it is indirectly available, that means we will be able to find out a left recursion only after some number of steps. So, in that case we must allow the productions to be substituted, that is by using the low order productions for the higher order productions, and after substitution we will be exploring the left recursion which is going to be an immediate one. That is actually they are not immediate, but we will let the productions be substituted in various positions by using the low order productions for the higher order productions, and what will happen is after some stage the left recursions which are actually that is implicit or that is indirect will be explored, and we will be they will be converted into that is explicit left recursion. And once they are converted into explicit left recursion or immediate left recursion, by using the algorithm or the framework which we are going to study, we will be able to transform it into a non left recursive grammar. So, here is the algorithm available for us. If we say that there exists a left recursion, then definitely we wanted to have a production of the form, that is your A derives A alpha or beta. So, we know here that there exist two productions, and the first thing is the first alternate we have is A derives A alpha, where we have a left recursion, and it is not necessary that that should be exactly 1. It can have a situation like A derives A alpha 1, A alpha 2, A alpha 3, etc. And then we find another component beta. So, the meaning of beta here is strictly the beta should not start with A. So, now the question is, can you find such kind of alternates? Certainly it must be there. So, if you find that all the right hand side of this A are starting with the A itself once again, then the grammar is completely going to be an useless grammar, because it is certainly not possible to derive any string. So, the grammar whatever we have taken must have some valid strings being generated out of that. So, if you are finding the productions for a variable a is always a derives a alpha 1, a alpha 2, a alpha 3 etc. up to a alpha n, but there is no right hand side starting with there is any symbol other than the one available on the left hand side, then the grammar is completely an useless grammar. So, such kind of grammars will never be considered for constructing parsing table as their languages are not there, but definitely we find that after some number of there is alternates, there will be at least one or more number of alternate productions which are starting with any symbol which is not on the left hand side of the production rule. So, that is the reason why we have a derives a alpha or that is beta, that is what the general format of the production given. So, this is what the pair of left recursive productions that is for a, left recursion is because of a, and here we find that is beta is a non left recursive component. Now, how we are rewriting this grammar? So, the rewriting the grammar is means we will be going for writing the non left recursive component first. As far as this production is concerned, the non left recursive component is the beta, and first you write beta. So, a derives beta. So, since we are writing that is the production for a deriving that is beta, we are completely void of left recursion now. So, if I start a with once again the first alternate a alpha, left recursion is there, and if I start a with that is non left recursive production that is beta, then a is not going to be there. So, if a is not there, there is no question of having left recursion, but still we must know that that is whatever be the way we are writing or rewriting the productions to eliminate the left recursion, the language generated by the grammar should not be allowed to change. That is whether we are that is producing language by using the grammar which contains left recursion, or we go for producing the language of the grammar with the help of the new one which does not have a left recursion, the language of the grammar must be same. So, here we are having the production a derives a alpha or beta, and now for rewriting this grammar we will be having that is the left recursion gets eliminated. So, what you do there is a derives beta, and if I am simply writing a derives beta, then certainly actually we cannot generate anything from that is alpha, but we know that it is going to be there is a beta followed by there is any number of that is your alpha, that is going to be the entire that is collection of strings generated by this grammar. So, we need a connectivity, so that beta followed by as many number of a's, that is alphas we wanted to have as output. So, for that connectivity we will introduce a prime. So, a prime, a dash or a prime as part of the right hand side, and now this is going to be a new variable, that is where a prime is going to be a new variable, and we cannot leave this as it is, because if you leave it as it is, then the grammar becomes once again a invalid grammar. So, we must go for expanding this a dash, and what this a dash is supposed to do. So, we know that beta followed by any number of alphas is going to be the there is the output of this particular language, that is production, that is a language. So, we must have a production which generates as many alphas as we wanted to have. So, your a prime gives you alpha followed by a prime, and we must have an end also. So, if you are always having a followed by that is a prime, and it will be a never ending process. So, we will be always having a dash deriving that is alpha followed by a dash, and we will not be able to find out an exact sentence which contains only terminals. So, to generate a terminal sentence or a sentence which is valid, we must have some end for that, that is when do we stop generation of the your alpha. So, for that we introduce another production called a dash, that is a prime derives that is epsilon. So, we have actually you are given only two number of productions, a derives a alpha or beta. Now, we are having three number of productions, one is a derives beta a dash or a prime, and the next one is a prime derives alpha followed by a prime, and the next one is a prime derives epsilon. So, this is the framework being used for that is converting the given left recursive production into a non left recursive production. but this framework can even be expanded for there is more the number of choices, like for example, if you are having A derives A alpha 1, A alpha 2, A alpha 3 etc. up to A alpha m, followed by once again beta 1, beta 2, beta 3 etc. up to some beta m or n. So, in that case also we can apply the same similar framework. So, first you should write that is A derives beta 1, beta 2, beta 3 etc., but with followed by A prime on each production, and then A prime will be your alpha 1, alpha 2 etc. up to alpha m or n, and followed by that your alpha each alpha I is followed by that is your A prime, and finally we must introduce one epsilon production for A dash. So, by using this, any production which has an immediate left recursion can be eliminated. We shall go for a short break and then we will continue. Welcome back. We have seen how the immediate left recursions are getting eliminated from the grammar by using the framework where A derives A alpha or beta is given means which has left recursion, and that will be rewritten into A derives beta followed by A prime, and A prime derives alpha followed by A prime or epsilon. So, now we shall see one example so that we will be able to find out how these things are getting eliminated. So, this is a production. Here we are having E derives E plus T or T. So, we know that the role being played in the general framework on A by is now being played by here it is E. So, we find E is left recursive. So, E derives E, it is left recursive, and followed by plus T is your alpha and T is your beta. We know that this T is certainly not starting with this E, and because of that we say it is, we claim this is going to be your beta, and now we must rewrite this production by using the framework which you have seen earlier. So, first we should write beta. So, we are going for E derives theta, sorry, E derives T here, since beta is T here. So, E derives T, and then for connectivity information we will be having a E prime here. So, E prime has been introduced, and if you are interested in generating only one T, then we can just stop with this, but if you want to generate more number of T's and all, then we should go for that is introducing this E prime, and now the expansion for E prime is, so what remains after the left recursive variable in the first alternate, that is the first production. The first production is E derives E plus T, and the remaining component after removing that E becomes plus T, and now the output is going to be E prime is plus T and followed by once again E dash, because that is going to be needed for generating as many number of times this plus T. So, if you wanted to have, and finally for the base case, that is for the termination, so we must have E dash deriving epsilon. So, this is what the there is output being produced after rewriting the grammar E derives E plus T or T without left recursion. So, this is what a direct case, but now here we have another grammar which is having two sets of productions, one for S and another one is for A. As far as S is concerned, we have capital A followed by a small a and followed by, or it can be even B also. We do not find any left recursion as far as the grammar the production 1 is concerned. But when you go for the production 2, we have 3 number of productions for A. One is capital A followed by small c, and the next one is capital S followed by small d, and the last one is epsilon. As far as AC is concerned, we have an immediate left recursion. So, this could be handled. So, if you are treating this SD and epsilon as beta 1 and beta 2, then it is not going to be the final solution. It is because of we will be having a derivation of the form S deriving capital A followed by small a in the first step, and by using the leftmost derivation or even the rightmost derivation, this A gets expanded to capital S followed by D, because of A is having 3 productions. So, this is going to be your SD being used there. So, now this derivation becomes S derives S. If you simply there is ignore this middle component, we will be having a derivation for S starting with S. So, once again it forms a loop. So, your S deriving S and it will go for once again A and then it will be coming for S. So, that is the left recursion. So, that is what I said. The left recursion can be even that is directly available or it may be available in an indirect form. So, if it is indirectly available, then we must explore the productions by doing substitution and bring it into direct form or immediate form. So, once it has been brought into the immediate form, then we can eliminate that by using the framework which we have seen. As far as this production is concerned, we rewrite this by using this format, that is we have S derives A or B, that is the first production. This first production has not been modified, and whereas the second one is concerned, after substituting the right hand side for S, since we are having two number of right hand sides for S, so we will be having A derives AC, so that is left unchanged, whereas your SD becomes AAD and SD once again becomes BD, and because of this AA we have AAD here, and because of this B we are having BD here. And in the case of epsilon, it is not a left recursive rule, so that can be simply left as it is without any modification. So, as a result of the substitution, so we say that this S is a low order production and your A becomes the higher order production, and the low order productions are being substituted into higher order productions wherever it is needed, provided they are available on the leftmost position. Suppose if you are having that S somewhere in the middle of your production, and that need not be disturbed because that will never be creating any left recursion. So, we are concerned only about the variables which are available on the leftmost end of the right hand side. Here we had S as the leftmost position. So, that is the reason why we are expanding that S by using all possible alternates for S. So, we will be having A derives AC and A derives AD and A derives BD and A derives epsilon. So, now everything is explored and we have brought every that is left recursive rules into that is immediate left recursion, and we find that A derives AC is left recursive, A derives AAD is left recursive, whereas A derives BD is not left recursive and A derives epsilon is also not left recursive. So, when you are rewriting, you leave the first rule without any modification, we will be having S derives AA or B, no change, and when you go for the immediate left recursion elimination, you look at the second rule, we are having A and this becomes your beta 1 and this becomes your beta 2. So, first you write beta 1 and beta 2 followed by just for connectivity information A dash or A prime. So, we have A derives BD, that is your beta 1 followed by A dash and the epsilon followed by A dash. Since epsilon is empty, when you are concatenating epsilon with A dash, we will be having only A dash. So, that is your first production, and the second production is going to be A prime is giving you. So, what remains after the left recursive variable? So, here is C is remaining and here AD is remaining. So, if C remains, then A dash derives C A dash is the output, and if AD remains, then A derives there is going to be A prime that derives that is AD followed by A prime, and then for the final that is terminal case or the base case, we will be introducing epsilon. So, that is going to be A dash derives epsilon, and do not be confused with A derives epsilon here. A derives epsilon is already beta 2. So, that has been already incorporated into this production A derives A dash. So, this becomes a new production being generated as a result of transforming the non left recursive immediate left recursive productions into a non left recursive production. So, now we have 4 sets of productions, 3 sets of productions, one for S, one for A and another one is for A dash. So, whether the left recursion is available in a direct manner or available in an indirect manner, we must eliminate them so that the grammar will become completely free from that is left recursion, and it will be used for successfully constructing the parsing table. Here we have the simple procedure for that is eliminating the left recursion. So, we have that is first we need to arrange the variables in the order something like A1, A2, A3 etc., That is what we have done. As far as the previous grammar is concerned, we got two variables, one is S and another one is A. We are ordered in the manner that S followed by A. So, S is the first one and A is going to be second one. And now for that is we will go for the substitution. So, we will be taking the first production, substitute in the second, third, fourth, etc. And when you take the third production, we will substitute 1 and 2 into the third production. When you go for the fourth production, we will substitute 1, 2, 3 into the fourth production, like that. So, we have the condition that is if it is of the form A I derives A j and that is gamma, then this j becomes a low order production. We will be going for substituting all possible rules for A j in the A I production. First, you should know what are the productions available for A j. The productions available for A j are that is del 1, del 2 and finally up to that is del k. There is A j as the expansions delta 1, delta 2 etc. delta k, and by substituting this A j productions into that is your A I productions. So, we will be having delta 1 gamma followed by delta 2 gamma and finally it is going delta k gamma. So, this will be your new productions. So, this may explore and that is give you an immediate effect of there is immediate left recursion or may not. And if it is generating any immediate left recursion, it will be of the form A I derives A I alpha 1 or A I alpha 2 etc. And if it does not create an immediate left recursion, once again it may either start with the terminal or with the non-terminal. If it starts with the non-terminal, once again it will be subjected for the substitution, so that at the end if you find there is left recursion which is in immediate form, we will go for eliminating them with the help of the previous there is formation. So, that is eliminating the immediate left recursions among all the A I productions. So, do this as long as substitution and that is substitution as well as your expansion by or rewriting are possible. So, this is how we are eliminating the left recursion, and the next issue is with the left factoring. So, here we have the framework. The productions may be of the form A derives alpha beta or alpha gamma. A production is said to be left factored. So, if there exists a common prefix among various alternates. So, if you are having two alternate productions for some variable and if both of them are starting with a common prefix, the problem is for some sentence both seems to be applicable. If both are applicable, but actually there will be only one exactly applicable, the other one may be looking like applicable, but may not be completely applicable for us. But we will not be able to decide which is the correct production by seeing the common, that is one or two number of symbols. It is because of there exists a common factor. So, now this common factor must be completely eliminated, so that the ambiguity being created for expansion can be removed from this grammar. So, look at this grammar. So, we have A derives alpha beta or it is going to be alpha gamma. Alpha is common across both the alternates. So, we will rewrite by that is this framework here, where first you find out what is going to be the common factor. The common factor here is alpha. So, you write it and then you introduce A prime once again, because of the entire essential form is not over, still we have something more to be appended with this alpha to produce the actual essential form. So, for that we introduce A prime, and for the A prime now you rewrite whatever remaining. We have beta here in the first alternate and gamma here in the second alternate. So, you will be having either beta or gamma. So, for example, that is if you are looking at the grammar which you have seen for the dangling else, which has common factors, one is going to be your S derives ICTS and another one is going to be ICTS ES. Among these two productions we find that ICTS is common factor. So, you put it first. So, the new production will be S derives ICTS followed by S prime, and for S prime from the first alternate we do not have anything. So, it is going to be epsilon, but whereas from the second alternate we will be having E followed by S. So, we will be rewriting the production such that the common factors among various alternates will be completely eliminated. So, when you are finding some string, to derive the string, when you are proceeding with the top down parser, we will not be having any ambiguity in deciding what will be the correct option, because always there will be only one that is production which will be matching for the current context. So, that will be taken as the input product, that is production for expansion, and expanded, finally we will be getting the sentence being parsed. That is the left factoring concept. So, we have seen that both left recursion and left factoring. So, left recursion is the one where we are having productions of the form A derives A alpha, and left factoring we have productions of the form A derives that is alpha beta and alpha gamma, and both are supposed to be removed from the grammar, so that this grammar will be useful for that is your top down parsers. As far as the questions are concerned, we may be given some there is grammars which are having left recursion, and they will be asked to remove the left recursion. So, for that we should know there is how to identify whether there is an immediate left recursion or an indirect left recursion. So, if indirect left recursions are there, then we must substitute and then go for first of all making it as directly, that is immediate left recursion, and then rewrite it. Similarly, for left factoring also, you find out whether there is a common factor available across the various alternates for any production. So, if they are available, bring that common factor first, and for then the remaining you just introduce A prime or B prime, something like that, and then rewrite the new productions. So, that we will be having the grammar without any left factoring. So, that is about your left recursion and left factoring. So, with this episode is being over. Thank you all.